Resultant. The properties of force, moment, and couple. Were developed in the previous sections. Now we are ready to describe the resultant action of a group or system of forces. Most problems in mechanics deal with a system of forces, and it is usually necessary to reduce the systems to its simplest form to describe its action. The resultant of a system of forces is the simplest force system of forces is the simplest form to describe its action. Which its combination can replace the original forces without altering the external effect on the rigid body to which the forces are applied. Equilibrium of a body is the condition in which the resultant of all forces acting on the body is zero. So we have a definition for equilibrium. Is the condition in which the resultant of all forces acting on the body is zero. This condition is studied in statics. When the resultant of all forces on a body is not zero, the acceleration of the body is obtained by equating the force resultant to the product of the mass and acceleration of the body. This condition is studied in dynamics. Thus, the determination of resultant is basic to both statics and dynamics. The most common type of force system occurs when the forces all act in a single plane, say the xy plane. The most common type of force system occurs when the forces all act in a single plane, so all act in a single plane xy plane. For example, consider this picture. F1, F2 and F3 in this picture. F1, F2 and F3 applied on the body. We obtain the magnitude and the direction of resultant force R by forming the force polygon shown in the part B of the figure, where the shows the all forces, the F1 and F2 and F3 were shown in the polygon. Form. Where the forces are added head to tail in any sequence. Thus, for any system of coplanar forces, we can write this relation. For any coplanar force system, we have R and magnitude of R and the theta with x direction. Graphically, the correct line of action of R may be obtained by preserving the correct line of action of forces and adding them by the parallelogram law. We see this in part A of the figure, this picture. For the case of three forces where the sum R1 and of F2 and F3 is added to F1, obtained R. The principle of transmissibility has been used in this process. At first, we continue the force line action to obtain the point for F2 and F3. We use R1 and F1 direction to obtain the final answer R. The next section is algebraic method.